introduces the military's high-tech vanishing act, a masterful blend of contours and composites that makes aircraft invisible to radar. This sky-high sleight of hand is now coming down to earth and setting out on the high seas. Daunting, deadly, top secret. Now, stealth technology on Modern Marvels. Sleek, lethal, powerful. The F/A-22 Raptor opens a new era in stealth technology. The revolutionary concept that's changed the face of aerial warfare since the 1990s.
Compared to anything else that's out there, this airplane is head and shoulders above those jets. We can get to places very quickly before people would expect us, and with stealth there, they don't know that we're going to be there.
The Raptor, like all stealth aircraft, reduces its observability in 5 distinct areas: visual, acoustic, heat, infrared, and most of all, radar. Radar, short for radio detecting and ranging, locates an object by transmitting ultra-high frequency radio waves. By measuring the time taken for the radio waves to be reflected back to the transmitter, the location, speed, and size of the object can be determined. One of the best ways to reduce the chance of detection is to create aircraft with the smallest possible radar cross-section, or RCS. An aircraft's RCS can be reduced in 2 fundamental ways. First, specially designed contours built into the airframe help deflect radar away from the source. The earliest stealth aircraft accomplished this using flat panels. The latest generation of stealth has curved panels. The second way for a plane to minimize its radar cross-section is through the materials that coat the airframe. Those materials help absorb or trap radar signals rather than reflect them. The composition of these radar-absorbing materials, or RAM, remains classified. With the F/A-22 Raptor, stealth technology has come of age. Manufactured by Lockheed Martin in partnership with Boeing and Pratt & Whitney, it measures more than 62 feet long, with a wingspan of more than 44 feet. Yet its radar signature is smaller than a sparrow's. In the past, achieving such invisibility required compromising aerodynamic performance. Case in point, the Raptor's revolutionary predecessor, the F-117A. But the F/A-22 is as speedy and nimble as it is stealthy.
If you compare the F/A-22 to a 117, you'll notice that ours is very smooth, curved shapes, and basically where that helps us is in the aerodynamic capabilities of the airplane. We are much more agile, much more capable than the F-117, which is basically a series of flat plates, which greatly affects their aerodynamic agility capability.
Designing a stealth aircraft is really not rocket science. First thing we do is we take care of shaping. Once you take care of the shaping portion of it, you've done about 90% of the stealth. And in the area of shaping, what we worry about is what we call planform shaping.
Planform shaping is an airframe design strategy in which leading edges are aligned along identical angles. The goal is to predict and control the direction that radar waves bounce off surfaces, a phenomenon called scattering. The Raptor sports another key element of effective shaping. Unlike conventional planes, which feature protruding navigation and communications gear, the Raptor integrates such equipment seamlessly within its airframe.
As you look at the airplane, you notice that it's basically smooth. There are no antennas or anything sticking out of the airplane that you would see on other aircraft. And that's because we've taken all the antennas and sensors on the airplane, and they're embedded in the leading edges, trailing edges in the aircraft itself. You can see right here, this large panel is actually our UHF radio antenna. There's one on the bottom here, there's one on top of the wing. If you were to look at an F-15 or F-16, you'd see a blade antenna, and that's what they're using, where ours are smooth like this.
Using the Raptor's advanced stealth technology, a pilot can soar undetected in enemy airspace long enough to deliver his deadly arsenal and return home unscathed.
The reason we carry all the weapons internal is for stealth reasons. With everything internal to the airplane, you don't have an increased radar cross-section, so people can't see you as well. And when it comes time to employ the weapon, the doors open quickly, the missile is released, and then the doors close back up to put us back in that stealthy configuration so people can't see us.
Since straight lines or seams on a plane easily reflect radar, every door on the Raptor features saw-toothed edging, from weapons bays and landing gear to maintenance access panels. The Raptor's cockpit canopy is another triumph of stealth design. Radar can penetrate a conventional canopy and reflect off the cockpit interior and the pilot himself. To counter this effect, previous stealth generations were forced to compromise the pilot's view. But the Raptor's radically redesigned 11-foot long canopy grants the pilot a 360-degree view.
To make sure that we don't get scattering from the cockpit or from the pilot's helmet, we put specialized coatings on the canopy that provide it the conductivity so it looks just like a metal plate and energy reflects off of that rather than going into the canopy and reflecting back out.
The Raptor's stealth technology is coupled with an advanced propulsion system called Super Cruise. New Pratt & Whitney engines with increased thrust-to-weight ratios enable the Raptor to cruise for extended periods at supersonic speeds without the added thrust of afterburners. Earlier jet fighters, known as legacy aircraft, use afterburners when they need an extra boost for carrier liftoffs or for supersonic speed.
Typically, when we go into an afterburner mode on a jet engine, that's accomplished by effectively just squirting jet fuel into the exhaust system and lighting it off. We don't need to do that to be able to go Super Cruise.
Super Cruise enables the Raptor to go faster, farther, and longer than any previous jet.